array. Okay, so now this is like our case 2. So when you have endfire array, see in case of endfire array, what is the direction of maximum radiation? See, I am having antenna here and antenna here. I'm just connecting this point and I'm just extending. My direction of maximum radiation will be along the array axis. It can be in this direction or it can be in this direction also, but the direction of maximum radiation is along the array axis. It can be either in this direction or this can be either in this direction also. That's also okay. It can be in any one of the direction. So once my maximum direction of radiation is in this direction, definitely this theta is equal to 0, or if it is here, theta is equal to pi, my observation point. Okay, if the observation point is here, theta is 0. If it is here, theta is pi, because previously I have taken here observation point, that's why pi by 2. Now I have taken my observation point here because I am choosing the observation point in such a way that there is a maximum radiation. Now endfire means I have to make a maximum radiation along the array axis. This is the array axis. Okay, along the array axis. Okay, so that means what? Endfire array means maximum radiation. Endfire array, the maximum radiation is along the array axis. The maximum radiation is along array axis. Okay, along array axis. Then when it is along the array axis, the theta can be either 0 or phi. You take general formula, that is psi is equal to beta d cos theta plus alpha. When my theta is pi or 0, then what is cos theta? Cos 0 is 1, cos phi is minus 1. Then that means what? Simply that is plus or minus beta d, because cos, you know what is theta? Theta can be either pi or 0, then that is plus or minus beta d. Then alpha. Then you know that whenever you want to have a maximum radiation in particular direction, the direction may be anything, but if at all, if you want to have a maximum radiation, the psi has to be 0. You may have a confusion. Then what is the meaning of maximum? Then you are taking psi always 0. Psi can be something else. When psi is something else, you'll get side lobes. You'll get side lobes. When psi is equal to 0, you'll get the main lobes maximum. Maximum of the main lobes. When psi value is something else, you'll get the maximum of the side lobes. Okay, that in detail and all we are not going. Okay, but for maximum radiation, the maximum value of the main lobe, then definitely psi is equal to 0. Then from this, what is clear? My alpha has to be plus or minus beta d. So in the previous case, my alpha is 0, but in this case, my alpha is plus or minus beta d. Then I am not changing the current. Okay, so no change in the current. That means what? Here also I have to use equal current, but phase I have to vary. That means what? Say if I am using current I here I have to use current I with the phase of plus or minus beta d, with the phase of progressive phase shift of alpha. Some phase shift I have to use alpha. What is that phase shift? What is that progressive phase shift? Because if it is a two conductor, then two antennas, then simply that is a phase shift. If I am having n antennas, then it is simply a progressive phase shift. I will tell you later what is n antenna per case. Then this alpha, okay, it is of some phase difference. That phase difference is decided by beta and d, because d means distance between the antennas. Beta, you know, anyway, that is once if you fix the frequency, that will fix the lambda, then beta is fixed. So somehow you are getting some phase shift. So when you want to have a endfire array, you have to introduce a phase difference for the second antenna, but that phase difference is decided by plus or minus beta d. So once if you excite the antenna with the same current and with the phase difference that is decided by this value, definitely the direction of maximum radiation will be either along the theta is equal to 0, or it will be either along the theta is equal to pi. Okay, so that's the idea. The maximum radiation will be along the array axis. The maximum radiation will be along the array axis. That's the idea of the endfire array. Okay, then you just find out what is beam width between the first null, what is half power beam width here. For endfire array, what is the beam width between the first null, what is the half power beam width. But whenever you are writing beam width between the first null and half power beam width, that is clearly not for 2 element array, that is for n element array always. This is for n element array. Okay, because this can be extended to n element array. When you have n element array, then what is the beam width between the first null? Then what is the beam width of our beam width? Similarly, for here also I have written some formula. I think where, sir, have I written or not? This is also for n element array only. The beam width between the first null formula is for n element array only. Very quickly I will tell you what is n element array. Now we are discussing about 2 element array, but this formula is for n element array. This is beam width between the first null, then half power beam width is simply half of this one, that is 57.3 degree divided by L by lambda, That's for n element array. Okay, so far we are discussing what is two element array. Now we'll see what is n element array. We'll see what is n element array.